Hello guys, today we will learn about optimization technique. So as it's the first lecture, I would like to throw some light on introduction. So I can say you something like if you know the meaning of optimist, it's like someone who sees opportunity in every difficulty. Okay, and if you have heard the word pessimist, it's just opposite of optimist. Okay, the person who is pessimist always sees the difficulty in opportunity. Okay, so the optimization comes from the word optimist, and to find the opportunity in every difficulty, it's a literal meaning of optimist and optimization, and but the real meaning of optimization is either finding the minimum or the maximum of something. It may be the profit, it may be the loss, it may be whatever else, but it is just a point where you want the maximum or minimum of something. Okay, so let's start the topic with a problem. Okay, so there is a problem. I would like to explain you. Okay, there are two products. There are two products. Okay, two products, A and B, using resources R1 and R2 to produce 1 unit of A. Okay, and A requires 1 unit of R1 and 3 unit of R2. Okay, to produce the same here, to produce 1 unit of B, to produce 1 unit of B, it requires 1 unit of R1, 1 unit of R1 and 2 unit of R2. So a company has 5 unit of R1 and 12 unit of R2. Okay, these are the total number of resources that are available in a company. So the company has total number of 5 units of R1 and 12 unit of R2. Okay, now 1 unit of product A gives a profit of rupees 6. Okay, so we can write here 1 unit of A gives a profit of rupees 6 and 1 unit of B gives a profit of rupees 5. Okay, so the traditional method that you will use in a normal brain, how the normal brain will use, it will calculate manually instead of putting the variables and finding the answer. So how it can be done? Initially you may think in this way, that this is R1 and this is R2, and here you can mention the resources R1 and R2. You want to use the full resource so that you can get the maximum profit. It is a normal thinking, human thinking. So in R1 you used 1 unit of R1 and then 3 units of R2, then next 1 unit of R1 and then 3 units of R2, and these combination produce what? Product A, and product A gives 6 rupees of profit, and product again the product A comes and you get the 6 rupees of profit. Then 1 unit of R1, then 2 unit of R2 gives a product B whose profit is rupees 5. Again you can repeat it twice to get all the resources to be used so that we can get the maximum output after that. Okay, this is the combination after which the all the resources are get fulfilled, or sorry, it get used, and the maximum number of A that can be produced by using all the resources is 2, and the number of product B is 3. So in this way you can get the solution manually. Okay, and the profit comes to be 27. 15 plus 12, 27. So this is a traditional way you used, but there is a very easy method that is known as the linear programming problems, the method we will use. So first we will construct a model of solution, okay, for solving the problem. So in this model we will draw a square here, okay, we will draw a square, then we will mention the resources R1, then resources R2 and A, then B, okay. In R1, so resources that are used to produce product A is 1 unit of R1 and 3 unit of R2, okay. So 1 unit of R1 and 3 unit of R2, and to produce a product B we use 1 unit of R1 and 2 unit of R2, okay. So, and what is the profit of selling product A? Profit is rupees 6, so we will write here 6, and to sell B, the profit that comes from the product B is rupees 5, isn't it? Okay, now the total resources available for R1 is 5, so you write here 5, and total resources available for R2 is 12 as mentioned in the question above, okay. If you have forgotten the question, I can show you here. You can see I have written here 12 units and 5 units, okay. Okay, so we will formulate a formula. So let us consider total number of products A produced is X, okay. So I am writing for you total number of A produced is X and total number of B produced is Y. So you got total number of A and total number of B that is been produced, okay. So after reading the question we can get to know that there are constraints, okay, that the company has 5 units of R1 and 12 units of R2, means you cannot use more than 5 units of R1 and 12 excuse me 12 units of R2. So if total number of A produced is X and total number of B produced is Y, then what will, if total number of X is the total number of A produces X, that means here X plus Y should be less than equals to 5. Did you get it? I think you may not have. You see here, this is R1, A takes R1, B takes R1, okay, resources. So if total number of products of A is X, then how much R1 is used? 1. So total number of products will be, for suppose 2. So R1 will be used, how much? 2 units of R1 will be used. And in the same way, if 2 units of X is produced, then there will be 3 into 2x, that will be 3x of R2 is produced, yes or no? So in seeing this thing, we can formulate here 3x plus 2y. X is for A and y is for B. So 2y is less than equals to how much? 12. Okay. And the profit that we need to maximize is equals to 6x plus 5y. Okay. So how we can maximize this? By equating with 5 and equating with 12 and solving the equation here. X plus y equals to 5 and x plus y equals to 12. I guess 3x plus 2y equals to 12. So how we can solve this problem? Multiplying 3 in the equation 1. This is equation 1, this is equation 2. I am doing it very fast. So I hope you know these all things. Okay. So 3x plus 2y equals to 12 and y is equals to 3. If y is equals to 3, then x is equals to 2. That means number of products A is 2, number of products B is 3. Did we get this answer as we got above? Here 2 number of A and 3 number of B. That means the model works, isn't it? Yes. So this thing is known as linear programming program, that is LPP. So that's all for today, and keep learning, keep exploring. Take care. This is SR signing off.